More than 1.4 billion tons of agricultural products are harvested each year. But what amazes the world isn't the number itself, it's how China manages to achieve it. Once quiet fields now operate like massive open-air factories, where the sound of engines has replaced the swing of sickles, and mechanized production lines run continuously with second-by-second precision. Each harvest season unfolds like a perfectly programmed campaign, blending the power of machinery, data, and large-scale management. The sight of fleets of harvesters moving in sync across seas of ripe crops is not just a display of productivity, but a declaration of industrial strength rising from China's countryside. Experts call it the Steel-Green Revolution, a turning point that could help the nation surpass the United States and dominate the era of high-tech agriculture. As the world's largest rice producer, China feeds more than 1.4 billion people, nearly 20% of the global population. To maintain that leading position in the age of technology, the country has restructured its entire rice-growing process, transforming traditional paddies into an automated cultivation network powered by machinery and data. From the moment the first rice seedlings are planted, instead of hundreds of farmers bending down to hand transplant each stalk, modern self-propelled rice transplanters now handle the entire job. With an 8-row design and an average speed of 1.5 hectares per hour, each machine can match the output of about 60 manual workers, saving both time and labor on a massive scale. Equipped with the Beidou navigation system and auto-balancing sensors, these machines move with near-perfect precision, each seedling placed exactly 2.5 centimeters apart, in straight, laser-like rows. As the wheels roll across the field, thousands of seedlings are planted in perfect synchronization, forming a mechanical assembly line in the heart of nature, a vivid symbol of how technology is steadily reshaping the rhythm of China's rice fields. Of course, rice harvesting is the moment when technology proves its power most clearly. In the past, with a sickle in hand, farmers bent over ripened fields, spending 5 to 7 days to harvest just 1 hectare of rice. Today, across vast golden plains, compact combine harvesters work tirelessly, finishing the same area in just 3 to 4 hours and yielding around 2 tons of grain per hectare. At the front, rotating blades cut the stalks close to the ground, feeding them into the threshing chamber inside. There, a series of drums, sieves, and fans separate the grains, clean off the chaff, and discharge the rice through a rear outlet, where workers stand ready to catch the steady flow of grain into sacks. Once full, the bags are replaced while dry straw is spread evenly back onto the field to fertilize the next crop. Mechanization has reduced labor by up to 90% and cut grain loss to under 3%. Amid the vast expanse of the Yangtze River Delta and the rice fields of southern China, fleets of harvesters move in perfect sync under the setting sun, creating a flawless rhythm of machinery. Across the rolling hills of northern China, apple season no longer means farmers climbing ladders in the cold wind. It's the steady rhythm of fruit-picking robots moving between rows of trees. Each robotic arm is equipped with high-resolution 3D cameras and color recognition vision systems that can detect perfectly ripened apples, even those hidden behind dense leaves. Once locked onto its target, the soft silicone gripper gently twists 180 degrees to detach the stem and places the fruit carefully into a separate tray, all in less than a second. Each unit can harvest about 6,000 apples per hour, matching the output of roughly 10 human pickers, with an accuracy rate of 98%. Pressure and ripeness sensors let the robot adjust its grip to prevent bruising, while the central processor records the size, weight, and freshness of every apple. That data is instantly sent to a control hub, allowing engineers to monitor and optimize productivity in real time. Solar panels mounted on the chassis power the entire system, enabling non-stop operation day and night without external charging. Self-balancing crawler tracks allow it to move steadily across uneven or muddy terrain, maintaining stability throughout the process. Every synchronized motion of its steel arms amid the crimson orchards reflects China's remarkable leap toward precision agriculture, where technology, efficiency, and nature work seamlessly as one. In the sun-baked lands of northwestern China, sunflower season reaches its brightest moment as thousands of giant blooms bow toward the horizon, waiting for harvest. Across golden fields, workers move in neat rows, using sickles to cut heavy seed heads and lay them face up on the stems to dry under the hot sun. Once the shells darken and the seeds reach the perfect crispness, massive machines roll in to take over. Teams of workers collect the dried heads and toss them into the feeding chute of the waiting harvester. Inside, a threshing drum spinning at 600 RPM pulls each flower in, using centrifugal force to separate the seeds from the disc. High-power fans blow away husks and dust, while multi-layer vibrating sieves sort the kernels by size and density, keeping only the firmest seeds. Heat and humidity sensors constantly adjust the drum speed to maintain an ideal dryness of 9 to 10%, meeting export and oil pressing standards. At the rear, an automatic conveyor moves the clean seeds into the storage bin, ready for bagging on the spot. Each machine can process 2 to 3 tons of seed heads per hour, tripling productivity compared with hand harvesting. And though still short of full automation, like America's giant harvesters, China's rapid pace of mechanization is quickly steering it toward the throne of global agricultural technology. And when harvest season arrives, the tomato fields of eastern China ignite like a vast crimson ocean, where massive machines move in unison to the rhythm of the season. Each harvester, over 12 meters long and weighing nearly 18 tons, is powered by a high-performance diesel engine and a multi-axle hydraulic drive system, allowing it to maneuver steadily even on soft or muddy terrain. At the front, a rotary drum spinning at 600 revolutions per minute cuts the stems and draws entire clusters of fruit into the processing chamber, while the vibrating sieve below separates soil, weeds, and small stones. Inside the machine, high-resolution cameras and multispectral optical sensors detect up to 98% of each tomato's ripeness and size with precision. The perfect fruits are placed onto soft, air-cushioned conveyors that gently transfer them into trucks moving alongside, while unripe or damaged ones are released behind, falling back onto the field as organic fertilizer. On average, a single harvester can process 50 to 60 tons of tomatoes per hour, equal to the work of more than 250 human laborers, with a damage rate of less than 2%. Compared to American harvesters that can handle up to 70 tons per hour but require completely flat terrain, the Chinese models may be slightly slower but are far more adaptable to uneven fields and use up to 15% less fuel, a clear sign of steady progress in China's agricultural mechanization. Inside greenhouses filled with the bright red hue of ripe strawberries, there's no longer the sound of workers bending to pick fruit, only the soft rhythm of robotic arms moving with precision. This is China's latest strawberry harvesting robot, a symbol of precision agriculture in the age of automation. Each unit is equipped with multispectral cameras and depth sensors capable of identifying ripe berries by color, brightness, and shape. Once a target is detected, its mechanical arm extends, using a soft silicone gripper to twist the stem gently, separating the berry without scratching its delicate surface. The harvested strawberries are placed into temperature-controlled trays, preserving their freshness and natural flavor throughout the process. Real-time data on yield, ripeness, and plant condition is transmitted directly to a central control system, allowing farmers to monitor and optimize productivity instantly. On average, each robot can harvest 250 to 300 kilograms of strawberries per day, the equivalent of about 15 manual workers. Costing around $20,000, these compact mechanical farmers are redefining how strawberries are harvested and managed across China's high-tech agricultural farms. Across the endless white cotton fields of Xinjiang, the gentle hum of engines has replaced the harvest songs of the past. Today, China's giant cotton harvesters have taken over a task that once required hundreds of workers. At the front, high-speed rotating drums carefully pull the cotton from its stems, sending the fluffy fibers through pneumatic tubes into the main storage chamber. Once full, the machine's automatic compactor compresses the cotton into massive round bales, nearly 2.5 meters wide and weighing about 2.2 tons, tightly wrapped in bright yellow plastic to protect them from moisture and desert dust. Each harvester can collect more than 30 tons of cotton per day, 8 times the productivity of manual labor, and requires only 2 operators. When the day's work is done, specialized trucks equipped with hydraulic cranes lift the enormous bales onto their beds and carry them to collection sites, where the journey of each cotton fiber begins a new chapter. In an age when the eat green, live healthy lifestyle is spreading across the world, the demand for fresh leafy greens in China has been rising rapidly year after year. To handle the massive harvest volume while keeping every leaf fresh and intact, farms have begun using semi-automatic vegetable harvesters, a solution that is both efficient and labor-saving. Inside the lush greenhouses, the compact machine glides smoothly between rows of crops. At the front, a pair of parallel cutting blades, manually adjusted for height, skim close to the soil, slicing through the stems without bruising the leaves. Just behind, a slanted conveyor belt gently lifts the greens upward, laying them flat and even, ready for workers to collect into crates. Thanks to its tracked drive system and small electric motor, the machine operates steadily even on damp soil, without needing a complex power setup. On average, one unit can harvest between 200 and 300 kilograms of greens per hour, matching the output of 10 to 12 manual laborers. The operator only needs to control the speed and cutting height, while the machine takes care of cutting, gathering, and conveying the produce with ease. Simple yet highly practical, these small innovations are helping Chinese-grown greens reach consumers faster, cleaner, and fresher than ever before. As winter approaches and the ground begins to cool, the carrot fields of northeastern China burst into activity. Instead of farmers bending over in the cold soil, massive harvesting machines now roll steadily across vast orange fields, a vivid symbol of China's growing shift toward mechanized farming. Each machine, nearly 10 meters long and weighing about 14 tons, is equipped with a dual digging system and an inclined conveyor belt that lifts, separates, and cleans the carrots right in the field. At the front, twin blades dig deep into the soil, gently raising the roots without breaking them. Behind them, spinning rollers shake off excess dirt, while high-powered fans blow away dust and debris before the carrots move on to the main conveyor. The clean, intact carrots are then transferred directly into a truck moving alongside, while damaged or misshapen ones are automatically discarded back onto the ground to serve as organic fertilizer. On average, each machine can harvest 15 to 18 tons of carrots per hour, the equivalent of more than 80 workers. Although still about 10% less efficient than the top American models, the Chinese versions stand out for costing nearly half as much, running smoothly on damp fields, and being far easier to maintain. These bright orange giants show how technology is not only boosting productivity, but also redefining the rhythm of harvest across the world's most populous nation. Under the cool white lights of a modern greenhouse, rows of lush green cucumbers stretch out in perfect alignment, as if drawn by a ruler. In this quiet space, a very special farmer works tirelessly, China's next-generation cucumber harvesting robot. Without pause or fatigue, it moves slowly along the planting rows, scanning each canopy with a high-resolution 3D camera and optical sensors that detect precisely which cucumbers have reached peak ripeness. Once a target is identified, its flexible robotic arm extends, using a soft silicone gripper to gently twist and detach the fruit from the vine without leaving a single scratch on its delicate skin. Each freshly picked cucumber is placed carefully into a rear collection basket, while the robot continuously sends real-time data on yield and crop conditions to a central control system. On average, one robot can harvest 400 to 500 cucumbers per hour, or about 70 to 80 kilograms, a level of productivity that manual labor could hardly match. Priced at around $18,000 to $25,000, about two-thirds the cost of similar Japanese robots, but offering nearly the same performance? This compact machine can operate steadily for 8 to 10 hours, consumes little electricity, and moves smoothly between crop rows. Amid the booming demand for tropical fruits, bananas, the familiar fruit of the southern regions, are now being transported in an entirely new way in China. At massive banana plantations where steep terrain makes truck access nearly impossible, farmers have come up with an ingenious solution, an agricultural cableway system that turns banana transport into a journey through the air. Right after being cut from the tree, each banana bunch weighing around 30 kilograms is hooked onto stainless steel hangers connected to a cable line stretching across the valleys. The entire system runs on electric motors, moving steadily at a speed of 3 to 4 meters per second, fast enough to save time, yet gentle enough to prevent bruising. Along the route, support towers standing 5 to 7 meters tall lift the cables over forests, ravines, and small streams, sending the banana bunches floating through the air toward the collection point. On average, each cable line can transport more than 1,500 banana bunches per hour, the equivalent of about 50 manual laborers, while saving fuel and minimizing damage during transport. Today, China's farmlands are no longer just places of cultivation. They've become open-air factories powered by machinery and precision technology. From fruit-picking robots to self-driving harvesters, every movement reflects a nation's ambition to master innovation. Could this be the model for the future of global agriculture? Share your thoughts. And don't forget to follow Mandarin Tech to discover more groundbreaking agricultural technologies shaping our world.